Well, I've been doing research in the Grand Canyon for 27 years. Here in the Grand Canyon, you've got exposed to view virtually a whole slice through Earth history. And so that's why it's important, because it's been used at Exhibit A for millions of years and biological evolution. And that's why it's important that creationists also come to the Grand Canyon and say, no, it's Exhibit A for creation and the flood. What's the choice?
I can do either one, Andrew. Can you deepen up over there?
Over here, okay. We're coming into the Tackett sandstone here, outcropping at river level. This is our target rock unit. This is our first sample. This is the same sandstone as in the Carbon Canyon Fold. It's a good spot because it's something like 5 miles from Carbon Canyon Fold. If the sediments were still soft, we wouldn't expect to find any difference with the sample here to the sample in the fold. It's shattered on it. I'm marking where the bedding is so we can reorient it in the lab. TSS standing for Tackett Sandstone Sample 1.
Let's stop for a second though and go back a little bit and talk about, first of all, where the rocks came from and how you got them and why and so forth, so that we can kind of lead up to what the research is about.
Well, a lot of people ask me the question, now why the Grand Canyon? Let's start with something basic. The reason why the Grand Canyon is a geologist's paradise is that you've got this giant slice in the earth where the canyon, and exposes all these layers. It's in a desert. It's almost a showcase in the textbooks about all these different rock layers. And so the question is, when did they form? How did they form? What is their history? We now know that many of these layers that we see exposed in the walls of the Grand Canyon stretch, in some cases, right across the North American continent and beyond.
So Andrew, the layer we were looking at in Grand Canyon is the
Tackett
sandstone that's down near the bottom of the Grand Canyon. We can trace that layer into the Colorado Rocky Mountains near Colorado Springs. We can trace it into the Black Hills, and we can trace that same layer up to Greenland as a continuous sheet with no breaks in it.
So that kind of an understanding of a layer that is so huge leads your thinking more to something global than just in something local.
So that tells you something not only about the scale, but we think the flood eroded away enormous sections of the pre-flood continents, then deposited that material in layers one on top of the other. It's like a stack of pancakes miles deep all over the earth.
And so when we talked about the layers, those layers are all formed as a result of sediment, right? Talk about those layers, first of all, and how they were formed, and the layers in that we wanted to look at and why we wanted to look at them.
We wanted to look at those specific layers because they're at the bottom of that huge stack. If those layers were still soft when they were folded, they can't be hundreds of millions of years old.